Hey guys, are we live yet? Are we live yet? Okay, I think we are live. Yeah, and not much to say. This is kind of like my first time live streaming, so I don't really know what to expect. Uh, don't know how. I don't really have like any experience live streaming before. This is kind of my first time. So yeah, uh, let's say like a little bit about myself. I am like I'm a software engineer by profession. I've been a software engineer for the last like 2.5 years, working as a pretty entry level software engineer in a company in India. Yeah, I'm basically from Kerala, India. Um, so yeah, I mean I don't know what kind of audience to expect, but I'm hoping for like I would probably get like a more you know uh, technical kind of audience. Uh, doesn't matter where they're from. That's why I'm kind of speaking in English rather than like my local mother tongue, I guess. Well, anyway, so I hope the I mean the idea of me like live streaming is pretty much like I do some like content. If you look at my channel, there are like few videos up, mostly related to like software, software engineering, AI, new tech, and stuff like that. That's what I do, and I pretty much do that. Like, I mean, I wish to do that pretty regularly, but that clearly didn't happen because if you look at my videos, the last videos were definitely like a long time ago, especially when you compare it to like something like uh, internet times. So it's like pretty long time ago. And also, yeah. So my intention was to like make content regularly, but the problem was that if I'm making like a long form video, then it would take like a couple of days to like record, edit, like make the script, record, edit, and do all the background stuff related to that, and it would take a lot of time. And also because I'm like working full time as a software engineer, I really don't get like a lot of time, especially like considering the working environment in like Indian software companies. So I really don't get that much time. I mean, like I like to like do other stuff as well other than like just like on YouTube. So eventually after like some time I kind of fell off. Really didn't like record much and post. So yeah, both my Instagram as well as like my YouTube has been pretty dull for a while, like couple of months at least. So yeah, so the hope is that I if I spend like a lot of time recording anyway, might as well like live stream and like share it live, and that way I can also use like repurpose that live stream video as like short videos and you know like full length YouTube videos, like 10-15 minutes YouTube videos, because like no everyone wants to like watch live videos. So for them, you can like watch like short videos. And also I think like maybe shorts, like YouTube shorts as well as like Instagram reels are a good way to like boost your profile, like get subscribers and like followers, because like they are I mean, let's face it, like everybody's attention span is pretty cooked right now. So everybody wants to like just doom scroll, so might as well. So I just uh, kind of want to put myself out there, like record the videos and like post online. So this way, like I can use the live recording and then like cut it up into like shorts and like long form videos. So my idea is like I would cover like a couple of topics in one stream, maybe like maybe some like technical presentations, or like covering more like new tools, new like AI tools, or like just coding tutorials or something, or like live coding sessions, maybe like live reactions to some like technical videos or something like that, so yeah, I'll probably like wish to have that. Yeah, right now starting out, I don't think like I have any views. Yeah, zero views. Nobody. So yeah, I mean, it's not, it's all right. You can, I guess, like if I continue, I'll probably get there eventually, I guess. Anyway, I don't know how like discoverability works in like YouTube regarding the live like videos. Do like people already have like established like subscriber base and then start live streaming, or like do you just like live stream and just like you know get viewers? I don't know. I mean, I've heard that like Twitch is also a good platform to start streaming. Uh, Not sure how. I mean, maybe can I like start Twitch as well? Uh, yeah, seems like I can. Let's see. Let's see. Go to Twitch. Not Twitter. Twitch. Mm. Yeah, I just started like live streaming on the like the menu panel. Am I actually live streaming? Like I don't know. Uh, like am I? Uh, am I live streaming? Yeah. Whoa. Okay. Am I live streaming? Yeah. Whoa. Okay. Yeah. So can I pop this out? Like mm, do I? I don't. I've like I've I've used to watch like Twitch streams, but I have no experience like actually streaming, so I don't know. I have no idea. Um, I don't know how this works. Yeah, pop out chat. Okay. Yeah, I can pop this out into the page, and yeah, guess like yeah. So I can have like YouTube and Twitch chat over here. Yeah, so I guess Twitch chat is also working. Not sure, like uh, yeah. Uh, Forgive me for like being such a novice. I have no idea how this works. This is like first time streaming. I guess like is this one like me? Like, am I the one like watching? Yeah. So this is like I am like simultaneously streaming into both Twitch and YouTube. So yeah. No, no idea how this like how this works out. I guess like let's hope for the best. Uh, yeah. So yeah, about me. Yeah, I've been following the AI news, like AI news and like technology in general. So I'm pretty into that space. Been covering like news and getting like really up to date. I like frequently follow like the model releases, tool releases. I like always look up at like GitHub trending, get like GitHub trending, trending. Oh, okay. Uh, I don't know why that happened. Yeah. Yeah, so I just look at the GitHub trending and like try out new projects. Like just see how it all works. This is like GitHub trending is probably like the most my favorite place to like look up, um, you know, like upcoming projects. Basically you can find out like what is new software in town, like what is trending right now. So yeah, this is how I like discover like cool projects. I try to like contribute to like projects, but till now I've never been able to. I don't know why, because like maybe I didn't like invest much time into it. But yeah, I would like I could wish to like contribute. Uh, yeah. Anyway, so yeah, but even though I am like pretty deep into the AI rabbit hole, I'm not like the typical like the majority of the AI influencers who will be like, yeah, AI is coming, AI is gonna replace the entirety of the workforce, and if you don't like keep up right now, you are gonna be behind, you are toast, and like there's nothing that you can do. The software engineers are dead, the white collar workers are dead, and there's nothing you can do. I'm not that kind of a guy. I'm a little bit like optimistic at least. uh, I think like AI is a good tool, and like it can really boost your productivity. And yes, I do believe like there will be displacement in the workforce, but I don't think it's like a complete replacement of humans level yet. I We could get there. I mean, I can see a path where we can get there, but there are a lot of challenges ahead, like the economics and like hardware. Even though people think like AI is a software, a huge chunk of the problem of AI is still hardware, like chips and scaling the inference to like a lot of people. That's still a very big challenge. So like to get the 100% of the workforce, or like 100% of all the companies to adopt AI in their like daily like business or stuff like that, it's a huge engineering challenge, in terms of like you need to get up the GPUs, you need to get up the server farms, you need to have the power grids, everything should be up. So it's a very gigantic task to like get to the level of like 100% AI use and replacing all the workers. So it's a faraway reality, I think, because like the economics doesn't allow to like speed up that fast, because like you can like solve software and the internet and the problems like that, like basically the layer of software very quickly. You can like maybe like make it more efficient, scaled up, and like make it more smart, but like trying to inference it into a lot of people is still very challenging. So it's a primarily a hardware limitation, because like yeah, exactly like I said before, we you need to have the like electricity grids and the infrastructure, which cannot be solved overnight. So it's a very big challenge. Probably like the chips and everything has to become like super efficient to have that to happen. So yeah, it's like a very challenging scenario, at least. Can I like do like that? Yeah, yeah, okay. This looks a bit better, I guess. Um, how does it look in the screen? Okay, I mean it's not bad, I guess. Maybe if I do like a little bit like this, screen like that, and like a little bit like this. Yeah, it can. I mean, I don't really want to like hide the stream chat, but it's okay. Um, yeah. Mm. Anyway, so yeah, like I said, like it's a very big challenge. So I'm not a skeptic. Obviously, I am like very much into like the AI can change the world, this is the future kind of a thing, but not to a point where like people like Sam Altman or like the guy, what's the name, Dario, the CEO of Anthropic, says like, yeah, white collar jobs are dead, like software engineering is dead in the 6 months, and like software engineering is dead in like the next 6 months, and he's kind of been saying that for the like last 3 years, and we are still like requiring software engineers. So yeah, that didn't really work out. I mean, I guess like in 5 like 10 years you probably have like, I wouldn't say like software engineers are gonna be dead. You still need like the application layer for like, the whatever technology is there at that time. Maybe like, yeah, it could be like super advanced and stuff, but still you need to have like an application layer to that. So yeah, software engineering will still be around. Whether it's the software engineers who actually do the engineering, yeah, I think the role of the software engineer is gonna change. Like, even right now, it's been a long time since I've like really go into the weeds and like hard coded code with my own hands. So it's been a while. So it's kind of a pretty huge of challenge to like, uh saw the software side of things. But eventually I guess it would be. But yeah, you would still need a captain to steer the ship. Is like, I am still not convinced like AGI is like possible, because I mean it is probable, but will it be certain? I'm not sure. At least I don't see a path from the current like flow things like LLM, the architecture agent. I don't think that will eventually scale up to AGI. Yeah, so that's about my overall like about me. That's what I kind of stand for. Yeah, and one thing I'm like very like optimistic about is the rise of like open source LLM models. I am a really big fan of like software like LLM models. I mean open source software in general, but like open source LLMs just hit different. Um, so yeah, I think like running the local models in your own hardware is the way to go in the future, because if you've been following the like AI inference part in the like last couple of months, or like last couple of weeks at least, you would have seen like a lot of issues popping up, especially regarding like Anthropic. Anthropic has been kind of like an like anti-consumer, to be honest, like in the last couple of like months. It's been like they've been like blocking like third-party tools using their APIs, like the Claude subscription, the $20 like $200 subscriptions. They've been blocking like OpenClaw, like Hermes, and even like Open Code from using the subscriptions. You can only use the API with the API with these tools. Now the problem with using API with these tools is that you don't get as much inference with API as opposed to the uh, like coding, like code coding plans. So it's like if you go to the website and yeah, if you go to the Anthropic like subscription sites, you would see like you have a couple of like subscription models. You have the free tier, the pro tier, and the max tier. Free, pretty useless. You can only use the web application with the free version. You don't get like APIs or stuff like that. With the pro plan, you can use the like Claude Code and API. With Max, obviously, you can do like a whole lot of new stuff. I think there's also like I think there is like uh, more plans, like $200 something. I'm not sure. I can't afford like max subscriptions, so yeah. Anthropic been pretty kind of anti-consumer in the case like, even if you have like the cloud code subscription, you can't use like third party harnesses. Oh, by harnesses I mean like stuff like open code or like OpenClaw, um, Pi, and even things like the uh, like Hermes. Yeah, you can't use that. And the reason is that when it comes to like these coding plans, you actually get a lot more inference than you actually pay for. So let's say let's consider like the pro subscription of cloud. You actually get more than like $20 for sure, because the thing is like at least they would give you like couple of hundreds or even almost close to like $1,000 of inference with this $20 plan. And why is that? Because like not everybody who has the $20 plan uses the $20 plan like effectively. So you can essentially like subsidize a lot of like advanced uses with that. And the thing is like they also like subsidize these coding subscriptions plans from their own pocket. So like investment money going straight to the subsidization. So yeah, essentially to like hook you up into um, the ecosystem, like Anthropic ecosystem. But the thing is like yeah, so if you use just the models from these plans, which means that you are like using third party tools, the cloud like Anthropic doesn't really have much of a control over you, like in terms of like if you use the pro subscriptions, you probably be using like Cloud Code, Cloud Cowork, so you are still in the like Anthropic ecosystem, and that's what they want. But if you go with the pro subscriptions to like like other tools, let's say like OpenClaw or Hermes or like Open or Code, you're essentially like using the extended like subsidized API for like a third party, like another harness, which they don't want. So they force you to use the API keys instead. So the API keys, you have to pay full price for the you know inference, full price for the inference, which is very expensive. If you go to like cloud models, it's like ridiculously expensive. Yeah, if you look at the price here, it's like ridiculously expensive. Yeah, yeah. If you look at the price here, you see there's like Opus 4.7 is like very expensive. GPT-5 is expensive. We'll come to GPT-5 later. About the cloud, like it's pretty expensive. It's smart, but it's really expensive. So if you use these in like your coding harness or like your agentic harness, you're cooked, because like you're spending like $100 in like couple of hours. So that's gonna be like you're gonna burn money like hell. So yeah, that's why they want you like use the official cloud code harnesses only for the subscription. And but the thing is like Claude is not the only one who's kind of like this. Even like other companies have a history of like locking you down. But I guess like Anthropic's definitely the like bad, the like the worst example of this. Like OpenAI is like way more like open to this than Anthropic. They allow you to use their subscriptions in like other harnesses. And nowadays like even Gemini, I think like DeepSeek, Kimi, Quen, all these have like subscription models for you to essentially like do subsidized inference for different harnesses. I personally went with OpenCode's Go. So open code go. Yeah, this is kind of my like favorite uh like um yeah yeah, this is currently my favorite like subscription AI inference subscriptions of all time. I'm, okay, current this is my favorite. Why am I stuttering so bad? Damn. Okay, so OpenCode Go is my favorite like AI subscriptions right now. So yeah, as you can see, it's like $10 a month and $5 for the first month, and these are the models that you get. You get like GLM 5.1, Kimi 2 like K 2.6, 2. The Mimo. This is from Xiaomi. Mimo 2.5 Pro, Quen 3.6 Plus, Minimax 2.7, DeepSeek V4 Pro, the Quen 3.5 Plus, and DeepSeek V4 Flash. Now the interesting thing is like DeepSeek V4 Flash and DeepSeek V4 Pro are like you get a lot of like inference from these like models. And by the way, this like requests for like 5 hours. And if you go to like artificial analysis and look at it, you can see that DeepSeek V4 Pro is like pretty up there. It's like even smarter than GLM 5.1, and like way smarter than like Quen 3.5. Yeah, so it's like you're getting a lot more than you pay for. Yeah, Kimi K 2.6 is the most like smartest like coding model right now, like open source coding model right now. So open code does give you like Kimi K 2.6, but it's expensive, so you don't get like that many requests. You get a lot of like DeepSeek, and you get a lot of like DeepSeek V4 Pro, and right now DeepSeek is my favorite like workhorse model. You can get a lot of work done because like there's simply more requests available. Like 30,000 requests in like 5 hours is a lot. I mean, you can definitely burn through it, but still, it's really a lot. I mean, I just subscribed to this like just a couple of days ago, and I still like barely use like 3-4%. So I mean probably like my company they have like Copilot subscriptions, so I use that in my like work. I only use like OpenGo in my like hobby project. Yeah. Yeah, that's about the open code. Mm, so yeah, yeah, OpenCode Go is definitely the best subscription, like AI subscriptions right now. All things considered, so yeah, I would I urge you to like check it out. It's pretty cool. Maybe like try it out. Kind of cool. Artificial analysis is like the best page that you can get to like just have like eagle eye views about the like latest coding models, or like latest any models. So this is the page like they list like a lot of models from different providers, scores that they got on the artificial intelligence index, coding index, agentic index. Pretty like straightforward. You get like a single like double digit score. Maybe it's out of 100. I'm not sure, but yeah, the score. You would get like cost analysis. So right now like DeepSeek V4 Flash is probably like the most like affordable, yet the most like intelligent. So basically, like this is the most attractive corner to be. You get like DeepSeek V4 Flash, and Minimax 2.7 is like it basically gives you like more intelligence per like yeah tokens per like the cost. Anyway, the cost. It's actually one thing is actually funny about the DeepSeek models is like if you go to like intelligence versus output tokens, the Okay, the output token. If you go to the output tokens, you can see that the DeepSeek V4 actually burned to a lot of tokens. It's thinking a lot, and I experienced this firsthand because like if you try to code with the DeepSeek V4, especially in the max or like the high mode, it just yaps, man. It just goes like, okay, I'm gonna do this, blah blah blah. Wait, was that really like how it's supposed to be? Okay, it's supposed to be like this, and okay, wait. And I saw like 100,000 waits. It is just painful to watch it think through. It eventually gets the job done, of course. It's like smart enough to get the job done, but it's just painful to watch. It takes a long time. It just goes on yapping and yapping and yapping. It's just so painfully yapping. And yeah, it's fast. The inference is fast, but still, it wastes a lot of tokens just yapping. So yeah, it kind of drives up the cost because it's still like reasoning a lot and like yapping a lot. So if they could like control this down and like make it more like token efficient, if they could like probably like release another version where it doesn't yap that much, they can definitely like be way more cost effective than they are right now. Yeah, so that's about artificial analysis. Yeah. Now, what did I want to do for now? Yeah, I actually want to like compare the different like ways that you can like run local models. Yeah, just a sec. Gotta get some water. Yeah, yeah. I kind of want to explore like the best way to like run local models in your PC. So there are a couple of ways that you can run local models in your PC. Uh, the Yeah, there are like several good ways to run local models in your PC. And I think like the most easiest way to run local models in your PC is like LM Studio. LM Studio. This is like basically kind of like an app, just an installable application that you can use, and it can like run local models inside. You can also download local models. You can like basically have like a chatting experience similar to that, kind of like in ChatGPT or something, like an online chatting experience. And not just that, it can also like serve up a REST API, like the Open API, OpenAI's like API endpoint. The exact same structure, the LM Studio can run it. So yeah, it's very straightforward to set up. Like you can download it for Windows. and just like install it like any other application that you can install. I'm using like Arch Linux, Cache OS, and like if you go to like Linux, you can get the app image. That's what I do. So if I can show you how it works, like essentially. So like LM Studio, yeah, this is pretty much the what the hell. Okay, I don't know why that is not working. Whoa. I guess it's like I'm probably using my GPU a lot, so maybe it cannot like run due to some like graphics driver issue. It used to work. I'm not sure why it is not working. Let's me check it. Like, what's the graphics usage? I mean, it's not that great. It's using just 1 GB of memory. I mean, yeah, about 2 GB of memory. So it's not that hard to push. I don't know why LM Studio is not working. Okay, it's hanging. It's freezing. Damn. Okay, let me just quit and retry. Okay, it's not. It's not even quitting. Okay, there goes my plan. Yeah. Fucking hell! What the? Uh, what? Why is it not working? Anyway, okay. Okay, we we will try another thing. Yeah, LM Studio is actually definitely a good way to run locomotives. The next thing is anything LM. Anything LM. This is one. This is like a. This is a one application made by a YouTuber. I mean, I'm not sure if he's a YouTuber in specifically, but he's definitely a developer who has a YouTube channel. So yeah, this is Tim Karambat. Okay, okay, Tim Karambat. Okay, I hope I didn't butcher that name. Anyway, this guy is pretty cool actually. I've seen like his videos a lot of the times. Like he covers like AI, like especially local AI. Pretty cool guy. I watch his like his videos. It's like he has a pretty good like takes on local AI, and of course being the creator of anything LM definitely helps to that. So this is like a pretty self-explanatory like anything LM basically does like anything that you can do with LLM application. So pretty straightforward to set up, just like and just like the other application. I can probably show you. I do have it installed. Yeah, so this is how it looks. Uh, yeah, this is how it looks. Why the heck is this not? Yeah, Twitch is very fast, but YouTube is. I don't know what's going on with YouTube, but definitely not working well. Anyway, so yeah, this is the anything LM application. So you can essentially just install the models that you want. So yeah, the LLM providers you can use other LLM providers as well, like cloud LLM providers, Olama, LM Studio, and even like anything LM also has their own like model. So yeah, you can like essentially like use the models that they have curated in this, and you can like import a ggf model. So I'll like maybe like import a model that I have. um where was it? Yeah, let's try Coin 2.5 2B or 4B. That's 3. Okay, let's try 2B. This is like an uncensored model, so I got it from Hugging Face. Yeah, the model was imported. This is Quen 3.5. Okay, let's see if this works. I haven't tried like GGF models. I've only tried like LLM Studio and Open Code and some other model from the catalog, but I don't remember. Anyway, okay, let's go. Anything LM Quinn? Yeah. Wait, there's 4.5. Oh, okay. Yeah. Right. An article about, let's say, speculative decoding. Yeah, okay. uh don't know what's going on in VTop. Let's see if it's actually using much GPU. Yeah, it's using like 400 more. Not that much actually. Is it working? Yo. Oh, okay. It's searching. Oh, okay, that's cool. Oh yeah, LLM Studio, like anything LLM does have like tools inbuilt in. It has like web search, scraping. So yeah, it's actually doing the RAG approach to it. Oh, this is actually pretty good. Yeah, I can get like 84 tokens per second in like the yeah, 84 tokens per second with I'm running. Yeah, I'm running the 4070 12 GB VRAM with like 32 gigs of like RAM system memory. I have like a i5 13600K. Yeah, so a pretty good PC for like today's standards. Not that bad. Like not the greatest, but like it holds on its own. So pretty good. Like so I get like 84 tokens per second with the Quen 4B 3.5 4B. Pretty good actually. And I'm really impressed by the agent use in anything LM. It's actually it went it like did the searching. It first went through like RAG memory and then did like the web search. That's actually pretty decent. Yeah, pretty good. There's a lot more stuff they can do. You can like link like photos and images, videos. Yeah, anything LM is actually pretty good. Yeah, another way that you can run like local models is definitely Olama. So yeah, next I'm gonna show you Olama, which is a really good tool to run local models. This is probably one of the OG like tools that you can use to run local models. It's been around since like ever since local models like started, like back in the times when like Llama 1 days. It's like pretty old, but it's actually really powerful, really good, like capable tool. It's pretty like straightforward to install. All you gotta do is like install the uh, comment. All you gotta do is like run this script on your like PowerShell. Yeah, on Linux, this is what you had to run. Mac OS, it's like pretty much the same. So once installed, you can use any of the models from the catalog. There are like cloud models too. They right now have like cloud inferencing attached to the CLI, but that's I don't remember how like long since they have the cloud options. It's been it. I don't think they had like it like that far behind. They definitely didn't have like the cloud option a couple of years ago. And yeah, running this is like really straightforward. All you gotta do is like just go to the model, go to the model page, and you get like the run command. So like yeah, which size that you want. You can even select like quantizations of the different models if you want. Pretty straightforward actually. So yeah, I've already cached this up. So yeah, if you can just like run it, uh, yeah, it will just first of all, if you don't have the models in your local machine, it will like fetch it up and like serve, then like run it. So like yeah, write article about speculative decoding. So yeah, it's thinking, and right now it's gonna output because this is a 2 billion model on like 12 GB VRAM and a 4070. This is like blazing fast. Yeah, I don't know. It's still yapping. Wait. I don't know if it's gonna go on a doom loop. Let's wait. Yeah, it finally outputted. Art of guessing, speculative decoding. Yeah, this is actually accurate. Not bad. Not bad for the 2 billion model. It's actually pretty accurate from what I see. Yeah, it's actually pretty accurate. Not bad for the 2 billion model. Yeah, the best part about Olama is that if you have it running, it has the local server running in the background. So you don't have to do anything. You just have to like just serve it up for once, and you would have a OpenAI compatible API at all times that you can use for like local inferencing. For example, you can use it in like VS Code, like coding extensions for maybe like autocomplete, tab autocomplete. Pretty good. You can use like 4 billion or like 9B models. 2B is not that great when it comes to like autocomplete. It's okay. But like if 4B and 9B would be like really good for like tab autocomplete in like coding environments. Yeah. What else? Yeah, this is another way. Uh, what else? Yeah, I'll show you the best way that like is like yeah. There's one more way. It's like VLLM. This is like a very industry standard software. It's not like something that you would like use to run on your like small device or like your PC. It's a very like a model that it's a library that you can use to like inference at scale, basically in like server environments. So yeah, like most like companies that do like inferencing at scale use VLM so that it gets like maximum throughput, maximum parallel processing, as well as like parallelization in terms of like the requests that you get from different users. So it's a very industry standard software. but it doesn't make sense running on your local machine, because in local machine you are using your machine for like different purposes. So you'll be like browsing the internet, or like coding, or like doing something else when the LLM is running in the background. But the problem is VLM like allocates all the memory and all the GPU that is needed for the uh, model. So essentially, you would not have anything left for your background processes, as well as your like the other tasks that you are doing in the in the desktop. So VLM is good if you have like a server environment, or if you are like making a home lab or something like that, and have like a server, or basically have like a mini lab or something. Then VLM is great. You can serve up like beefy models on your like server farm. But if you are using it on a personal computer, VLM is not the a way to go. Man, I feel tiring. Honestly, my jaw. I mean, I haven't talked this extent in a while, so yeah. Twitch. Where's Twitch? Where the heck is Twitch? What the hell? Wait. Why is the same over there? When it's like two different instances. What the hell? Okay, yeah, this is the Twitch. Okay, yeah. This is actually pretty funny when you think about it. Like, it's the depth mirror effect. Okay, now the best way to run like local models, in my opinion, is Llama CPP. So this is the yeah, this is essentially the project. This is incredibly powerful, and the fun fact is like Olama and LLM Studio both run Llama CPP in the backend. Both are like just like wrappers around Llama CPP. Now the best part about Llama CPP is like you can really like use it really powerfully. There's a lot of configurability. There's a lot of options. I can show you some that I frequently use in Llama CPP. It's actually pretty good. Um, yeah, both LLM Studio and Olama uses their own forks of Llama CPP. So because of that, it's usually a bit behind from the upstream Llama CPP. So yeah, sometimes they implement their own features, like new features that come out in the LLM world. Sometimes Olama and LLM Studio independently develop them and like put it out there in their application in their own forks of Llama CPP. Sometimes it takes a while for it to get into here because a lot of people are contributing in Llama CPP, and it's a pretty close, like tight community for like things. So yeah. Anyway, this is like very powerful. I will show you my setup. Yeah. So the way you can run it is like you can either go to the releases and get an installation. There are like compiled already working installations for like uh, Windows, Linux, Mac OS. I like to build it from like source, uh, so that I kind of like know what's going on. So I mean, the working is pretty straightforward. All you gotta do is like Llama server and like a link to the like Hugging Face repository All you gotta do is like do llama server and hf and then to a ggf repo in Hugging Face, and you can essentially run it up. And also, if you have like local models, all you gotta do is like you do llama CLI or like llama server dash m and your model file. That's really straightforward. So I'll show you. It's pretty much like you know, where the fuck was that? Dev tools. Yeah, I've stored like my llama commands. Essentially, like yeah. Yeah, this is one such of command. So I'll show you like clear. I'll show you the vanilla llama CPP first. So it's basically like yeah. This is a fork of the llama CPP. I'll get to that in a moment. Uh, First of all, I will show you the vanilla llama CPP. Mm. Yeah, this is the vanilla. What the hell? Yo, what the heck? Why is it not running? Okay, I just got the tools. Llama server? There's no llama server? What the hell? Yo, what? I mean, I remember I compiled it? What the? Yeah, okay, build. Bin. Yeah, okay, I'll do this first. Okay, so yeah, this is running the this is how you run the let's see, I'll clear this up and this is like a sample yeah, so this is a sample command that you can run to basically run llama cpp on your device. So yeah, this is the model file, this is the mmproj file. This is basically like model weights to support images, like it's a vision decoder. And then you have like the layers, cpu shifting, your like context size, your server, your port, flash attention, your like chat template. There's a lot more options, there's a lot more things that you can configure, but this is like a basic setup that you can run. So right now I'm using Qwen 3.5, Qwen 3.6 5B A3B, which is like a really good model. Yeah, so this is essentially the web address that you can go to, and the best part is like Llama CPP already has like a pretty good front end built into the server. So yeah, this is how it looks. Yeah, you can essentially chat it like any other application. So right now I'm gonna do the same. Write article about speculative decoding. Okay, so it's thinking. I'm getting like 28 TPS, which is not bad honestly. It's like pretty decent. Because like it's running, it's essentially running a 12B model, like a wait, what the fuck was I'm talking about? Um, yeah, it's using about like 12 gigabytes of VRAM, and I only have like 12 gigabytes of VRAM, so I can't like extend the context that much. It gets like really slow after some time, and sometimes even crashes being out of like VRAM. But the thing is, like, it's Quen 3.5, Quen 3.6, like A3, Quen 3.6, 35B, A3B is like the best model that you can run if you have like 12 gigabytes of VRAM and you can like run it in your machine. And it's actually really smart. I'll show you how smart this is. So if you look at the artificial analysis index, you can go to the index and like add in the 3.5, 3.6, 35B. Yeah, this is the 35B, and look at this. It's up here. It's better than 3.2, DeepSeek V 3.2. It's almost, it's like almost as good as GPT 5.4 mini, almost as good as like Gemini 3.5 Pro. Like do you realize just how powerful that is in like agentic index? In coding index, not that like good. It's like essentially around like DeepSeek V 3.2. If you go to the overall artificial analysis index, you can see that look at it. It's better than DeepSeek V 3.2, better than like Gemma 431B. It's better than HiQ 4.5, which I mean, granted, it's like a pretty old model at this point. Like HiQ is like the like smallest variant of Claude. But you know, look at this. The Quen 3.6 is almost at like 43 points, and the nearest like GPT 4.5.4 mini, GPT 5.4 mini is about 49 points. Minimax is like 50 points, so about like 7 points difference. And you have to realize this is like a 35 billion more parameter model. This could very well be like 200, 300 billion parameter models. This is definitely like 500 million parameter model. This is like almost like 20 times smaller when you compare it, and there's only like 7 point difference. That is insane. So yeah, this is like the best model that you can run right now. So yeah, the article is complete, and yeah, this seems about right actually. Speculative decoding, like oh yeah, auto decoding. Okay. Yeah, this seems okay. So yeah, this is how you can run a model on Turbo C, like Llama CPP. Now the best part about Llama CPP is like, if you are technical enough, you can run like different forks of Llama CPP. Not that straightforward as like Llama CPP, because like here you can basically run it with maybe um, just like the yeah, you can run it just with like the one executable from the already built Llama CPP executables. But when it comes to forks, you probably have to like compile it from scratch with the source code. but it's straightforward. It only takes like maybe like 10-20 minutes to compile the whole project. Pretty good actually. And if you go, yeah. So one thing that I actually want to show you is TurboQuant. Now, TurboQuant is a research paper by Google, which is actually a really crazy development, if you ask me, because it essentially lets you like shrink your memory footprint by like 50% right off the bat, and that is like crazy. So let me tell you how it works. Yeah, so there is something called KV cache, which basically translates to like key value caching. So what happens is that when you prompt the model with some like kind of prompt, some text, some like images or anything, what it does is it has a tokenizer built into the model, and this tokenizer converts all your input sequence into tokens. So essentially, the tokens are represented in like vector space, and these vectors are cached in the memory or in like key value pairs, and that is what KV cache is. So the more KV cache you can hold, the more context size that you can process. So more tokens that you can process, more data that you can input into the model. So the bigger KV cache that you have, the more context size. So which also means that the bigger context size that you have, the bigger the KV cache. So with increasing context, there is a lot of memory footprint that you have to use. A lot of VRAM is used for higher context sizes. So essentially, what is happening here is okay. I haven't talked this much in a long time, so kind of affecting my throat. Oof. Oof, man, I'm kind of tired to be honest. Like I haven't streamed. This is first time streaming, and it's like, oof, it's actually kind of tiring to be honest. Uh, yeah, I've been streaming for 1 hour. Okay. Yeah, I'll quickly show like TurboQuant and stop. Yeah, so basically, the more context size that you have, the more memory that you require. So higher context means higher memory footprint, which means like if you have like 12 gigabytes of VRAM, the model itself probably like just require like maybe 10 gigabytes of VRAM, but the KV cache might not fit in the 2 GB that you only have. So you have to drop your context size dramatically. Maybe you can only use like 32K of context, which is very small. It can like it can run on like many things like chatting, but you can't do like coding or stuff like agentic workflows with 32 context. You need higher context sizes. So essentially, Google introduced TurboQuant, and this is like a really clever way to how like what this works. So essentially, what this does is like it rotates the vectors and quantize the vectors so that it takes like less footprint. Now I don't exactly know the entire like technical details, but essentially, it is like representing the vectors in lesser space, and I think like it rotates the uh, you know Yeah, first of all, I think it rotates the vectors and also quantize the vectors in representing it in like one bit, essentially like from 0 to 1, or like -1 to 0 to 1 in like ternary bits. So I think here turbo quant represents in like either +1 or -1, so you can increase like the vector space would be like a lot of bits, but here it's represented in like 2 bits, +1 or -1, so it's like really compressed, but still maintains the accuracy. So if you look at the paper, like yeah, basically like the compression performance. So like KV cache basically has like really good performance, and like speed up, it massively speeds up, and the recall, like TurboQuant 4 bits essentially has like the similar recall. So yeah, this is a really good paper. And yeah, the TurboQuant is like really new. It's been like maybe like a couple of weeks right now. Whoa, it's from March, so it's been like 2 months. Yeah, it's been about like 2 months. Yeah, 1.5 month. Yeah, so the bright light is like hitting my head. Anyway, so yeah, implementations of TurboQuant for the various like inference engines is like still a work in progress. So I find out like there is a fork of Llama CPP that runs TurboQuant. It's from a guy called Tom in GitHub. It's basically like a fork of Llama CPP that he has implemented TurboQuant, referring to the research paper, and you essentially just have to like compile this and then run. So I'll show you. So right now I'm using like about 12 gigabytes of VRAM, so like about like 11.43 gigabytes, so almost like 90% of VRAM usage, which is like really high. Now I'm gonna show you what happens if I run the TurboQuant version. So this is like the TurboQuant version of command. So yeah, if you look at it, you can see that there's two new commands, which is like cache type V, turbo 3, and turbo cache type V. So essentially compression for the key and compression for the values. Now I'll show you how this actually works. Okay, so this thing is up already, and I'm gonna show you the exact same test that we did. So remember, it took like 28 tokens per second for the normal version, and right now I'm gonna like just run this again, and I'm getting like similar TPS. I usually get like a little bit higher, about like 35 TPS. So I think like probably because I'm streaming right now, the like graphics card can't push that much, because I'm also streaming and coding and uploading at the same time. So maybe can't get that much throughput. But the crazy part now is, look at the VRAM usage. From 11 gigabytes, I'm down to 7 gigabytes. With the exact same setup, exact same like model, exact same like context size, I am down to 7 gigabytes, which means about 4 gigabytes of VRAM is free for context and other processes. This is a very powerful technique. You see, I'm getting like almost the exact same quality, exact same speed, but now I am getting very less VRAM usage. It's not very less, but significantly less VRAM usage, about like 3-4 gigabytes of less VRAM, and that is like really significant. Oh my god, I didn't know streaming would be this tiring. What the hell? Yeah, so that's about Turbo CPP. Now I'll show you another version. Now I've been trying to like write about speculated decoding with the AI, but what exactly is speculated decoding? So basically, what you have is like essentially you have the main model, which is like the heavy lifting model, and then you have like a small drafter model, which runs ahead of the model. So every time the main model does a token prediction, the drafter model tries to predict ahead of the model, and the main model tries to like correct it. So the drafter would like draft the next couple of like maybe like 2-3 tokens ahead, and the main model would like validate it. Is it what it wants to guess? If it's not, it just discards it. If it is, then it just proceeds to select it. So what this happens is that the smaller drafter model will be like significantly faster. It will be like 10 times smaller, so significantly faster than the main model. Which means that the main model does not have to compute in the as much as to like output the same thing. It just has to check the drafter model. So yeah, that's essentially what the theory is. And now the MTP wasn't yeah, speculative decoding. Now now there's a version of the speculative decoding, like an implementation of speculative decoding called MTP. Which basically is like multi-token prediction. So yeah, multi-token prediction is a version implementation of speculative decoding, and essentially is like similar to speculative decoding, just more efficient and like predicts a little bit more ahead. So right now, the speculative decoding and like the MTP was only applicable for like dense models. What do you mean by dense models? So dense model is essentially like, what's the difference between dense model and like sparse model? So dense model is something like Quen 3.6 like 27B, which basically means like the entire model is this one large neural network. So it is like this one large set of neural networks that is like a part of one big model, one big set of weights. So essentially, it's just one model. One file. But when it comes to like the sparse models, essentially like it's called mixture of experts models. So these are like models that are like actually collection of smaller models baked into one big model file. So MOE or mixture of expert models are essentially like models that have like a controller, like orchestrator kind of a model that basically allocates the calculation to different expert models. So there will be like 10, 20 or like 30 different smaller models in this like one big model file. And these models will be like different models trained on like different data sets, different qualities. So there will be like slightly different capabilities in different contexts. So one would be like an expert in medicals, another would be an expert in mathematics, another would be expert in like construction, another would be like in computer science, etc. So all these like experts will be present in this one model, and depending on the like tokens, or depending on the the vectors that is coming in from the tokens, the orchestrator allocates it to the different experts. So if you're asking a question about computer science, it only has to activate the experts that are related to computer science. So there will be like 3 or 4 that is capable in computer science. So the orchestrator just allocates the tokens to the experts, and the expert activates and runs. So the advantage of it that so the advantages of the advantages of MOE is that at a time there will only be 2 or 3 active models working at the same time. So which means when it comes to a model like Quen 3.6 35B, only only 2 or 3 the 2 or 3 experts are loaded at the same time. So it's like A3B is active 3 billion parameters. So if two experts are active, there is 6 billion parameters active, which would be maybe 4 or 5 gigabytes of VRAM. So by activating just 1 or 2 experts, you can significantly drop the amount of resources that you're using, while still maintaining the intelligence of a full 35 billion parameter model. It won't be as good as a dense 35 billion parameter model, but it will be close enough. So yeah, that's essentially what MOE is. And yeah, so I'm kind of... Oh, my brain is now braining actually. So yeah, did I run it? So yeah, this is the code to run the yeah. So the thing is, I also found out an MTP variant of the Llama CPP. Yeah, so this is the... So yeah, this is a Hugging Face page of a user of a model that has implemented MTP prediction for Quen 3.5. So they essentially did the draft a model for the Quen 3.6 and basically graphed it into the main model. So he just basically combined the main model file with the additional drafter model into one single LLM model file. So yeah, you can run this variant. So there's a fork that he has made, that he has implemented MTP on, and I essentially compile this into the Llama server, and you can run it right now. If you want, I can maybe make a tutorial on how to essentially run it. Yeah, so this is up and running. Now let's see how MTP actually works. So if you know, the last time it was 27 VRAM usage, 27 last time, if you notice, it used 27... What the fuck? Okay. Okay, so I got 27 TPS last time with the turbo CPP, and also the normal Llama CPP. With the turbo quant, it didn't really improve, but the VRAM usage really dumbed down. Now, right now, I'm using about 8 gigabytes of VRAM. So this is a version of MTP. We are using 8 gigabytes of VRAM. I think... Wait a minute. Yeah. So what I essentially did is like I combined this. Okay. What I essentially did was I combined the MTP Git MTP fork of Llama CPP along with the Turbo Quant fork of Llama CPP into a single like repo. Basically like merged it together into like a single project and then compiled it. So right now my local Llama CPP project has both MTP as well as Turbo Quant, essentially giving the power of two things at the same time. So yeah, right now let's see how this works. I'm gonna do the same thing, same setup, and let's go. So look at this. I'm getting like 40 TPS right off the bat. It's dropping. It's obviously dropping, but essentially I got like increased throughput as well as low VRAM use combining Turbo Quant as well as MTP. This is like crazy powerful. I think you all if you have the hardware to run local models, you definitely should try running local models. This is like crazy powerful how local models have become in the last couple of years. Especially Quen models right now is like the most powerful local models that you can run on your system. They're like really capable. You can run like really agentic tasks today with using these models. Yeah, I'm getting like 28 tokens per second. Crazy, you know? Yeah. And the best part, I'm like just running like 9 gigabytes of VRAM down from the 11 gigabytes with just Llama CPP. Turbo Quant pushed it down to like 6 7 gigabytes because of MTP. You are essentially loading the like drafter model alongside the main model, so it requires a little bit more VRAM than like the normal setup. So yeah, if I use like MTP on the bare bones repo, it probably will run out of VRAM because like there's like so much going on. But right now, because of the turbo quant as well as MTP, I'm getting like more, not only more tokens per second, but also more context because I'm using like less VRAM. Crazy to be honest. Anyway, that's pretty much it, I guess. We should probably wrap it up for today. Yeah, my plan is I would probably stream like Tuesdays and Thursdays, so that I can get like pretty good content for the stream because like I don't think I can like ad lib my way through content. I probably need to like research and have like things in my mind that I need to talk about, and then like live stream because like I mean it's like technical stuff, so so I need to like research a bit like beforehand before I start to like stream. So yeah, I know and nobody's gonna watch this particular stream because like I see nobody in the stream. So yeah, I mean at least I get like content for the yeah, like shorts and reels. I'll probably edit tomorrow or like the after tomorrow or something. Yeah. Anyway, that's been it. See you on the next stream, I guess. Yeah. See you.